Hey, hi everyone. I'm Pranav Chastra, Senior Product Manager for AWS Local Zones. Thank you for joining us to learn about local zones and how they enable developers to meet data residency requirements or deploy low latency applications and also execute hybrid cloud migrations. In today's session, I'll describe what AWS Local Zones are, why we build them, and in which locations can developers use them. Next, I'll explain the developer experience of local zones. And finally, we'll discuss how developers are already using these zones to meet either data residency requirements or deploy low latency applications or execute on hybrid cloud migrations as well. At last, we'll end the session with a Q&A for any questions that you have. So working backwards from customer needs, let's understand different AWS Edge offerings, including local zones. Over the course of last 3 years, we have launched 3 different AWS Edge offerings, including AWS Outposts, Local Zones, and Wavelength Zones. AWS Outposts is a fully managed service that extends AWS infrastructure to virtually any on-premises facility for a truly consistent hybrid experience. It is designed for workloads that need to remain on-premises due to latency or data residency requirements. However, not every customer wants to operate their own data center. In fact, there are other customers who are interested in getting rid of their data centers entirely, and that's where local zones come into picture. Local zones allow such customers to gain all the benefits of having compute and storage resources closer to end users or on-premises installations without the need to operate their own data centers. On the other hand, Wavelength is designed to deliver ultra-low latency experience to 5G devices. Specifically, Wavelength embeds storage and compute inside telco providers' 5G networks, which help developers build new applications for 5G end users. And all of these 3 edge offerings here bring AWS services to more places with the same experience and benefits that developers are used to today. So now that you've understood different edge offerings briefly, let's discuss more details about AWS local zones. Logically, you can think of local zones as very similar to availability zones in regions. It's just that local zones are not physically co-located with the region, and instead they lie in a different physical geography. Now, there are some key benefits that you should keep in mind when you evaluate using local zones. First of all, local zones are managed and supported by AWS, meaning customers no longer need to incur the expense or the effort of procuring, operating, and maintaining data centers in various metros to meet latency or data residency requirements. Secondly, local zones provide elastic, on-demand resources with pay-as-you-go pricing that you are used to in regions today. Next, applications in local zones can use core services available in local zones locally and deliver a consistent experience across the globe, which basically allows developers to build applications using the same familiar AWS services, APIs, tools, and functionality that developers are used to in regions today. And finally, local zones provide developers a high bandwidth, secure connection between their local workloads running in local zones and those running in parent region, which basically provides them the ability to use the same APIs and tools to run latency-sensitive or residency workloads locally. While you can also connect seamlessly to the full range of services back in the region. So now the next logical question is, what services are supported locally in local zones? Overall, we support a number of services in local zones. In the local zones outside of LA area, we support core compute and networking services, including Amazon EC2 instances, EBS for block storage, Amazon ECS and EKS for managed containers, application load balancer for load balancing needs, Amazon VPC for integrated networking with AWS regions and other zones. And over time, we plan to add additional services, including TIE Connect and more EC2 instances to all these local zones. You should visit our features page on Local Zones webpage for a full list of supported services by locations. And apart from local services, all AWS tools work in these local zones as well. API calls are automatically logged via CloudTrail. You can also continue to use familiar and powerful AWS services like CloudFormation, identity and access management, and auto scaling to manage, secure, and scale applications in local zones. And you can access AWS services such as DynamoDB, S3, and others in the parent region in the same way as you do in regions today. So why did we launch local zones? So if you look at AWS infrastructure, it's the largest global infrastructure footprint with 26 regions, 84 AZs with one or more data centers, and over 230 point of presence. And this footprint is constantly increasing at a significant rate. We've announced plans for 8 more regions in places like Australia, India, Indonesia, Spain, UAE, and Switzerland. And at AWS, every region consists of multiple availability zones, typically 3 or more, each of which is fully isolated, discrete data center. And all these regions provide connectivity to the network and full redundancy. If you look at the last 15 years so far, Amazon Web Services has been the world's most comprehensive and broadly adopted cloud platform. So why did we launch local zones despite having 26 regions across the globe? And the answer lies in developers' expectations. Developers have told us that they have a significant number of applications that they want to run in AWS across the world. And the vast majority of developers get the necessary performance for their applications in public regions. However, for some of the more latency sensitive and residency workloads like real-time gaming, machine learning inference, real money in gaming, and hybrid migration, customers want AWS closer to their end users or to their on-premises installations. These workloads have traditionally required customers to procure, operate, and maintain their IT infrastructure in their own data centers or co-location facilities, which typically adds cost and operational complexity. Customers also told us that they had to build and run these application components with a different set of APIs and tools than the other parts of their applications running in AWS regions. And that's why we launched AWS Local Zones. Let's take a visual cue to talk more about a use case for edge customer who will benefit from local zones. Let's say we have a customer in Houston, Texas, or Phoenix, or a business has a corporate office in Denver. They're already served by 4 regions in the US. However, latency of applications deployed to region depends on the physical distance between the end users and the region, and the specific path traversed from end users to reach the applications in region. Typically, the latency to the closest regions is in the order of tens of milliseconds for these customers. But now these customers can benefit from 17 local zones across major metropolitan areas of the United States. Local zones minimize the latency required to connect to end users by bringing AWS services to edge in metropolitan areas, which in most cases result in single-digit millisecond latency. Now, coming back to the customer in Houston, before the customer had to connect to US East North Virginia region, now we have extended the region to the Houston, Texas metro area by building a local zone in Houston to serve the customer. The network path traversed between end users in the southern Texas area and Houston local zone is shorter, and the latency is lower and predictable. This is essential for low latency applications such as gaming or for hybrid IT deployments, including on-premises workloads. Though the local zone is not co-located with the region, local zone is connected with multiple high-speed redundant paths across the AWS backbone to its parent region. So next, where exactly are these local zones? We started with a single local zones in LA in 2019. However, developers outside of Southern California also wanted this capability for their end users. So in 2021, we started expanding local zones across the US and have launched 16 additional metro areas based on customer inputs and latency coverage needs. With these new local zones, customers are able to deliver a single-digit millisecond latency experience to end users across the continental US. And we're not stopping here. Building on the success we had in the US, customers internationally wanted local zones as well. And we've announced 32 new local zones, which will be made available across 26 countries starting later in 2022, including in countries like Argentina, Australia, Austria, Belgium, Brazil, Chile, Canada, Colombia, Czech Republic, Denmark, Finland, Germany, Greece, India, Kenya, Netherlands, Norway, Philippines, Poland, Portugal, and South Africa, which will basically enable customers to serve their end users across the world with even lower latency. So, how does local zones work? To get started, you first need to enable local zones for your account before you can start deploying resources to them. Once enabled, local zones look and behave similar to availability zones and regions. So you can extend your existing VPC from the parent region to a local zone by creating a new VPC subnet and assigning it to the local zone. Once a VPC subnet is established, you can simply select the subnet while creating local resources. Let's take a quick look at how it works in practice. As I said, AWS local zones are accessible from API endpoint and the console of the parent region. So to get started, you first need to enable the local zones for your AWS account before you can deploy resources to them. You can do that from the zone settings section of the EC2 console shown here in the diagram. Once enabled, local zones look and behave similarly to availability zones and regions. You can access local zones through the parent region's console and API endpoints. The image here shows the LA local zone, which is visible as US West 2, LAX 1A, along with other AZs in the EC2 console. The US West 2 in the name tells you the parent region, and LAX tells you that it is an extension of the US West 2 region and physically lie in the LA metro area. Now let's look at some of the concepts of local zones that we can see from the Describe Availability Zones API. The zone name US West 2 LAX 1A can be passed into APIs like create subnet, just like any other AZ. And the group name US West 2 LAX 1 is used to refer to group of local zones for a particular metro area. This group includes 2 local zones in LA, both of which are extension of the Oregon region. You can also see the network border group US West 2 LAX 1, which is used to allocate IP addresses that can be used with EC2 instances and local zones for local internet connectivity. Applications built on local zones start with a VPC, just like you use for applications on AWS today. Once the local zone is enabled, you can extend your existing VPC from the parent region to a local zone by creating a new VPC subnet and assigning it to the local zone. Here, you can extend the VPC from the parent region US West Oregon into the Seattle local zone by creating a new subnet and assigning it to the Seattle local zone. When you create a subnet in the local zone, your VPC is extended to that local zone, and your VPC will treat the subnet as any other subnet in AZ. And relevant gateways and route tables will be automatically adjusted. Local zones have their own connection to the internet, and select locations also offer direct connect as well. So resources created in local zones can serve local end users or on-premises installations with a low latency communications. Because local zones are connected to the parent region with multiple redundant, secure, and high-speed links, you can consume any regional service seamlessly, such as Amazon S3 and RDS. In addition, the management console for local zones is also accessed through the parent region, and all the logging and other metadata goes back to the region, which basically you can view in services such as CloudTrail and CloudWatch. Now that we have created a VPC and subnet is established to the local zone, you can simply select the subnet while creating local resources. For example, here, you can launch an EC2 instance in LA local zone by selecting the local subnet. Similarly, you can launch EBS volumes by selecting LA local zone, just like any other AZ in the region. Local resources are then ready within seconds, and you can manage these resources in the local zone, just like resources in AZs. For example, here you can see the instance that I just launched in US West 2 LX 1A, which is the LA local zone. Now, I talked a little bit about the customer feedback and the developer experience. Let's build on that and talk more about the use cases for local zones. First category of use cases is latency-based use cases, where customers deploy workloads on a local zone or use a distributed edge architecture to deliver single-digit millisecond latencies for their workloads. This includes customers like Supercell and Ubitus in the gaming vertical, and other social media companies who want to place select part of their applications in multiple locations across the globe to reach their end users with lower latency. Or customers like Netflix, who needs to access cloud services at a specific location that is in close proximity to their existing office to basically deliver low latency applications for remote desktops. Let's dive into some of these specific customer examples. The first important low latency use case is real-time multiplayer gaming, where gaming companies like Supercell deploy game servers for multiplayer gaming sessions worldwide to be closer to gamers. And a latency of 20 to 30 milliseconds or less is considered ideal for a good gameplay experience. Until now, these customers were using on-premises installations in various metropolitan areas to supplement AWS presence. However, now these customers can deploy latency-sensitive game servers in local zones to run real-time and interactive multiplayer gaming sessions, enabling them to provide end users across the world with a great experience. Next, we have media and entertainment customers like Netflix, who are migrating expensive artist workstations to local zone in specific metro areas like LA and New York. For artist workstations, latency is the key to having a jitter-free experience on a remote instance. And these customers typically require less than 5 millisecond latency from their offices or their animation hubs to virtual instances. With Direct Connect, most of our local customers, for example, in LA metro area, are able to achieve as low as 1 to 2 millisecond latency from their animation hubs to LA local zones and run latency-sensitive workloads such as live production, video editing closer to artists. Let's look at the architecture for low latency use cases. As discussed, when you create a subnet in the local zone, your VPC is extended to that local zone. And local zones have their own connection to the internet. So resources created in local zone can serve end users or on-premises installations with the low latency communications. In this example, you can create an internet gateway and use IPs dedicated to the network border group of local zones for local internet egress or ingress to end users or on-premises installations. Next important category of use cases for local zones is hybrid cloud migration. This includes customers who are interested in hybrid deployments or migrations in specific locations. This is a common pattern that we've seen across local zones, where customers like MindBody are using local zones to migrate complex and interdependent applications from on-premises to AWS cloud. Let's take an example of MindBody, who had workloads running in their own on-premises data centers in LA metro area. Such customers have told us that it can be daunting to migrate a portfolio of interdependent applications to the cloud. And now with the direct connect to the local zone, customers can establish a hybrid environment that provides ultra-low latency communication between applications running in the local zone and on-premises installations, which basically enable customers like MindBody to migrate applications incrementally and simplify migrations by enabling ongoing hybrid deployments. The architecture diagram illustrates this type of enterprise hybrid architecture. As I mentioned, by utilizing Direct Connect in conjunction with the local zone, customers can establish a hybrid environment with low latency. As time progresses, the on-premises applications can be migrated to cloud in an incremental fashion, simplifying the overall migration process. Here, customers can set up a cross-connect at the direct connect point of presence in the metro area and connect to local zone resources directly by leveraging DX Gateway, which allow them to achieve single-digit consistent low latency for migrations. The last category that I want to talk about is data residency use cases. As a customer, you may operate in geos where regulations dictate that data and infrastructure reside in specific countries or states. Alternatively, you may do business with public sector entities where contracts specify where applications are deployed. Or lastly, your enterprise may be in the process of migrating to the cloud, but as of yet, not ready to move to the closest region for either InfoSec or other reasons. In these situations, customers can configure their data to remain on AWS Local Zones using Amazon EC2, Amazon EBS, Amazon FSx, or other services available locally in local zones. In order to ensure that unique data residency requirements are met, we recommend that you work closely with your compliance and security teams for confirmation. So now that we have discussed various use cases, let's discuss how local zones can be used to further improve higher availability for applications. Several options exist, but care must be taken during design to ensure residency and single point of failure considerations are taken into account. Overall, customers can partition their workloads between a local zone and a region to achieve higher availability, similar to how they partition their workloads between AZs in the region. They can also partition between two local zones in nearby metros, or even between two local zones in the same city if that exists, such as in the LA metro area. Another option is to partition between a local zone and AWS Outposts, either hosted in the customer's own data center or placed in a co-location facility. Finally, the customer can also partition between a local zone and an existing data center, which is useful in the use cases where customers are trying to reduce the number of self-managed data centers that they have. They'll be able to use Direct Connect to connect their on-premises installations to the local zone. And all in all, many options exist, and we suggest that you work with AWS specialists or partner when architecting these options to ensure all requirements are met. Finally, from a pricing perspective, instances and other local resources running in local zone have their own prices that might differ from parent region. EC2 instances in local zones are available in on-demand, or you can also purchase savings plans. For pricing information, you can visit the pricing section of the respected services and filter pricing information by choosing the local zone location in the dropdown. And when it comes to data transfer, local zones are considered same as AZs in the parent region today. For example, data transferred between EC2 instances in the local zone and Amazon S3 in the parent region is free, just like how it's free in the region. Now that we've explained how to enable local zones and provision applications in local zones, please go ahead and try those. As always, we're listening to your feedback and are working on adding additional local zones in new locations, along with the availability of additional services. If you are an AWS customer with a requirement for a very low latency or residency needs, then we invite you to check out new local zones. Thank you again for coming to our session today. I'm Pranaj Ashra, Senior Product Manager for Local Zones. You should check us out on aws.amazon.com to learn more about local zones and try them out.